Hello everyone, my name is Mohammad Gufran Khan and in this demo I will present HAL, a novel dynamic graph data management system running in memory capable of correctly and efficiently maintaining a graph state even when updates to the graph are received out of order. HAL is the first and to our knowledge the only system currently capable of doing this. Dynamic graphs play a crucial role in data management applications, including real-time monitoring systems and anomaly detection in IoT networks. In such applications, graph updates such as edge insertions and deletions are continuously received. However, these updates do not always arrive at the graph database in the order they were originally emitted. We call these updates out-of-order updates. We show this in our demo via graphical user interface. In our example, suppose the first update emitted by the stream time is insertion of edge from vertex 1 to 2 at stream time 1. This update is placed in the transit area, which holds updates that have been emitted but have not yet reached the database. At the top, we show the so-called ground truth graph state. This is an artifact we built exclusively for the demo with the purpose of showing what the graph should actually be if all the updates were emitted from and received to the same site, thus without any delays. Of course, in practice, in a dynamic distributed graph setting, we don't have the ground truth. Next, a deletion of edge from vertex 1 to 2 is emitted at stream time 2, and it is also placed in the transit area. Now let's consider that this deletion update from vertex 1 to 2 at stream time 2 reaches the database first, that is, it is out of order. For our demo, we illustrate this by moving the edge from the in-transit area to the database area. The traditional graph database processing updates in the order they are received by the database ordered by database time. We'll check whether edge from source vertex 1 to 2 exists. Not finding a corresponding insertion recorded in the database yet, a traditional graph database system would just ignore the deletion. On the other hand, our system HAL process updates in the order they were emitted by the stream, ordered by stream time. When the deletion of edge from vertex 1 to 2 at stream time 2 is moved to the database, HAL does not ignore it. Instead, it places this deletion in our so-called staging area, where it waits for their insertions that may have been delayed. When the insertion of edge from vertex 1 to 2 at stream time 1 is finally moved into the database, the traditional system treats it as a new insertion and add the edge to the graph. In this case, the graph now incorrectly shows the edge from vertex 1 to 2 as present, represented by a dashed line in the graph state below the database table. If we look at the HAL graph state and compare it with the ground truth graph state, both correctly show an empty graph because the insertion arrived after its corresponding deletion. Now let's extend the scenario. A new update is emitted, inserting edge from source vertex 2 to 3 at stream time 3. When it reaches the database, the edge from source vertex 2 to destination vertex 3 correctly appears in both the traditional graph state and HAL graph state. Of course, it is the same in the ground truth graph. Now, if we query for a path between node 1 to node 3, a traditional graph database ordered by database time incorrectly shows that a path exists. In contrast, HAL ordered by stream time correctly indicates, just like the ground truth graph, that no path exists. This is because insertion of the edge from vertex 1 to 2 was out of order. Traditional graph database says may produce incorrect results when updates arrive out of order. Our system HAL correctly tracks and processes updates in stream order, ensuring that query results reflect the true state of the graph. The HAL system is not only correct but also highly efficient. It is built on two key data structures, the stream time sorted adjacency list, which efficiently handles both in-order and out-of-order updates while enabling fast graph analytics, and we use a secondary index hash table that efficiently and accurately associates the most likely insertion and deletion entries in the adjacency list, leveraging their stream time. Compared to prior systems which do not handle out-of-order updates, HAL's throughput is up to 73 times higher, while its advantage on analytics goes up to 357 times. Thank you for watching this video. I look forward to discussing this further at the conference.